Okay, here we have a question about similarity. When we have similarity, essentially what we're looking for is for two corresponding sides. And in this case, I can see that the 4 centimetres and the 10 centimetres both are on that diagonal. So what I'm actually looking for is the scale factor to get from one to the other. One way of finding that is just do the second, which is 10, divided by the first, which is 4, which you could have as 5 over 2, which is in fact 2.5, okay? So essentially the scale factor here is times by 2.5, not 2.4, 2.5. So if I know the scale factor, I can do the same for every other side. So in this case, what I've got is 3 times by 2.5, which is 7.5. And that would be in centimetres, so that's the value of x. Another way that I've done this in the past is actually, if I get rid of all this, sometimes you can't see them, so I used to draw a little triangle. I know it looks about the same size as the first one, but I used to look at these two sides, 4 and 10, and say, well, what is a common factor of both? And the common factor of both is 2. So what I used to do is use a 2 centimetre so to connect the two. So to get from 4 to 2, I divide by 2, and to get from 2 to 10, I times by 5. Then what I can do is I can do this for any other side. So this 3 I divide by 2, so this side is 1.5. And then to get to the x, I can do 5 times 1.5, which is, once again, 7.5. You may think, well, the first way was easier, but this method can be quite handy when you've got a slightly bigger diagram or you've got different sides on there and you want to move backwards and forwards. The reason is that if I go back from this one, I can divide by 5, and if I want to go up to this one, I can times by 2. So that's sometimes a nice technique if we do similarity.